Back in 2020, my favorite year ever, I had a vision that one day we'd be able to create a function as humanity, right? That could take in as much text as you wanted, a question, and which would return an answer to that question. That sounds very familiar, right? Today we have tools like ChatGPT and Cursor and Claude that answers any question that we have, way better than Google. We also see two types of debates online. There are people that think that the models underlying ChatGPT are alive, and there are people who think the complete opposite. They think it's all fugazi, it's all hype, it's all fake. Today I want to talk about this function right here, this main important function. Today we have this function, and this function right here has changed the entire ecosystem in tech. I want to talk about something really simple. How can computers understand human language? What makes the AI tick? Before I get started, I just want to give a quick disclaimer. I'm not an ML engineer. However, I've actually worked with these concepts not only academically but also professionally. I've been thinking about this problem for a really long time, and I'm so happy that today we actually have this. This is actually one of the most based shit I've ever seen in my life. ChatGPT stands for Generative Pre-trained Transformer, right? This is the transformer that they talk about. Now you see how complex this looks? We're not going to be talking about this. All we're going to be talking about is this. The input and the output that this model uses. You can ignore this for now, okay? This part right here. You can ignore this part. We're going to be focusing on these things. The language that the computer uses. You see this word right here, right? Embedding, right? What is that? Well, the embedding is the underlying principle behind how computers understand language. For us, it's simple. We read this information and we can parse it right away, right? But how do you give all this information to a computer? We can't just hard code a bunch of strings with a bunch of if-else statements. We can't do that. That shit doesn't scale. Well, the solution is this, embeddings. The language of a computer revolves around mathematics, okay? I'm assuming you're probably a full stack engineer or something like that, so we won't go necessarily really in depth in the whole math and the ML behind this. But what is important is understanding what exactly the computer is thinking when we give it all this text in ChatGPT, for example. An example of an embedding is this. Let's say we give the computer the word dog, right? What we want is some sort of mathematical representation of the word dog. And ideally, we want the computer to also know what a dog is, right? Thus, very smart people across the globe a few decades ago understood the importance of creating embeddings. Eventually, we as humans created functions that took an English language, or any language for that matter, and that outputted a numerical representation, okay? They were able to give a neural network a shit ton of English text and somehow found a way to extract the underlying patterns and the relationships between each word. I'm not going to go too in depth in the math behind it, but all you need to know is this. The whole concept behind embeddings is to understand the patterns and the relationships between each vector in this vector space. Okay? In front of you, you see a 3D graph, right? This 3D graph that I can manipulate. In reality, these vector models are trained on hundreds of dimensions, okay? But because humans cannot perceive above 3D, I've made this 3D example for you. Let's just assume that this is a 3D world. You see these axes here? You see these axes here, right? This red one, this green one, and this blue one. This is arbitrary, right? This is just an example. In reality, each of these dimensions within this vector is a sort of concept or a semantic meaning between these words. Let's just assume that these first three values correspond with these concepts or these semantic relationships. For example, the green one is status in the world, this red one, the gender, and this blue one is it natural or not. Let's say we had a few example words, right? These words right here, and we got the embeddings for them, and we took the first three values and we plotted them out in this 3D graph. The creators of these models wanted a way to group these words together in semantic meaning. But then not only in 3 dimensions, but hundreds of dimensions, okay? The most well-known application of this is word2vec, which, as the name already suggests, you put in a word, you get a vector out. They used a few techniques to train this model. I'm not going to go too in-depth into it. If you want to, you can look it up. The coolest part about having a numerical representation of a word with respect to embedded semantic meaning is that now, because you train this on so many concepts, right? Hundreds of conceptual paradigms, is that now you can do math over these vectors, okay? For example, let's say I had a vector here with a certain coordinates, right? Now we're looking at a 2D graph. Okay, let's say we had cat here and dog here, right? Now we can use any kind of similarity metric to group these vectors together. So now I can take the vector of cat and I can take the vector of dog and find the distance between them in various different ways. For example, you have cosine similarity and you also have Euclidean distance. You can choose your own distance metric. And now what happens is that you can see the similarity between the words. For example, king and queen will have a very high similarity, but cat and computer will not necessarily, right? Depending on the axis or the dimensions that you use. If you use the whole model, you get a different output. If you just use the first three values, you'll get a different output naturally, right? Coming back to Word2Vec, right? I remember the first day I saw this in class. It was super cool, man. Super cool. So let's say you had the vectors for king and man, right? So king would be here and man would be here, right? You can see that in terms of status, it's neutral. It's at 0, okay? But then you have the difference between man and woman, right? So woman is here and man is here on this side of the axis, okay? You can see that king and man share the same gender, right? The x value on this, like let's say this is x, right? The x value would be similar, so queen and woman, right? Let's say you took the vector of king, right here, and you took the vector of man right here, and you got the difference, so the difference in height here, right? You got this difference, and you added that difference to the vector of woman, right? Ideally, you would want a vector that would be close to queen. And the cool thing about Word2Vec is that it actually happened. It actually got a vector that was close to queen, which blew everyone's mind back in 2013 or whatever when this came out. Because now you were able to have a model that could reason with text, with English language. Granted, it was words, but whatever. This is the power of these embeddings. Super cool. So you see, the building blocks of this transformer model uses embeddings thoroughly. It is the language that this transformer architecture speaks. A few years later, after the Word2Vec paper came out, the very smart minds over at Google created the transformer architecture. They were trying to solve one very important problem. The fact that words sometimes have multiple meanings. For example, I deposited money in the bank and I sat by the riverbank. Bank here has two different meanings, but in the example that we saw below, right, these 100,000 or so words that this model was trained on couldn't necessarily get that meaning for the two different contexts. So what they did was they applied a bunch of stuff on top of these embeddings. Okay, so this whole process right here, okay, was a separate thing. Training this embedding models, right? Turning words, right, text that we put into for example chatgpt, turning them into embeddings and then putting them into a new neural network. And so this neural network, right, this transformer architecture did extra reasoning, like big brain cracked reasoning over the embedding models, which eventually gave birth to ChatGPT, which is super interesting. It's honestly, like, it's so awesome. Seriously, like, embeddings are the underlying backbone of all the AI stuff you see today. And now suddenly, with all this extra reasoning, right, they were able to distinguish the words within the context of whatever you were talking about. OpenAI obviously was the first one to popularize, like, using transformers and a chat interface, right? They've been shipping their vector embedding models for a while now. And these models are what underlie the training of the big GPT-4 or 1 models, etc. You can see here that these people, they use dimensionalities of 1500. So you would basically, a way to, like, a dumbass way to visualize it would be 1500 different axes. We can't obviously visualize that, but they're working with, at this point, thousands of axes here and concepts. And this neural network that is trained on this is now fetching all the underlying patterns on so many different conceptual, let's say, planes of existence. It's like magic to me how this happens. I obviously still don't understand the transformer model in depth, by no means, but what I do know is that these things are trained on how we behave. They're actually extracting the underlying patterns of humanity, which blows my mind. And this is why I personally think, I think that if you give these models, these large language models, like if you give them okay, this ties into something super cool. I'll show you. You probably know how processors work, right? So there are people out there who are hypothesizing LLM OSs, where the central processing unit of this system would then be an LLM, which reasons over text instead of zeros and ones, right? Binary. They'd be processing over text. So the cool part is, I honestly think just because they're reasoning, or they were reasoning in high dimensional space, like latent space, that's what they mean with latent space, right? They were able to grasp the underlying mechanisms and processes that happen within our world, right? The cool part is because these LLMs understand humans so well, the culture and all this logic stuff, and they were able to infer physics just from text. I believe that if you connect the right things, for example, video through cameras, or audio through a speaker and microphone, and you give it tools like browsers and other LLMs or whatever, right? And you structure that system in such a way where the submodules are mimicking human life, and you slap a while true loop on it. You just say while true, and you take this little robot or whatever you have, and you literally put it into the world, and you let it vibe, and you just let it go and perceive the world and reason and act just like that. You just throw it into the world. I think it would be grounds to say that it would be a living thing. It's for the first time in humanity, the first time ever, where we are able to create these beings, and I say that, I use that word lightly, beings that can perceive and reason and do shit. Therefore, I think they are probably alive. It's the first time we've ever done this. So I don't have the answer, and I don't think anyone actually does have the answer. This is some weird spiritual shit that is going on. We're training these models, these things, to act in the real world. And that shit honestly scares the shit out of me. But I know that the engineers that watch these kinds of YouTube videos, like you, for example, you're watching this video because you're an engineer and you like learning about these things. Whether or not you build like JavaScript applications at your job or whatever right now, it doesn't matter. Like, as long as you're some sort of engineer and you solve problems, I think that we're going to be entering an era where we're going to have these robots and these intellectual, like, badasses everywhere with us. And it's going to take us to a level where we don't know we don't know what to do. And the thing is, it's honestly this kind of vibes. It honestly gives me American frontier vibes, New World vibes, where the land is for us to take as engineers. We're so early right now, and I'm super excited to see what we do with this. Like, I toy around with these AI applications from time to time, not as much as I want to, but I should. But these applications are so immense. Like, bringing it back to what we were talking about earlier, right? We now have a way, like, I don't know how to stress this. We now have a way to actually reason, have these computers reason. And this is the fundamental building block, right? And now it has become, like, really intense with this transformer stuff, okay? I genuinely think that we're going to be, we're going to make it. We're going to actually make it. We're going to be living with robots and shit in no time. 5, 10, 15 years, whatever. Like, I'm 25. By the time I'm 40 and I have kids, I'll actually have robots in the house doing shit for me. And it's super cool because as an engineer, I can study this and understand this, and you can too, obviously. So yeah, man, super excited. Anyways, yeah, thanks for watching. Click the subscribe button if you want to know more. This was a very high level overview of what I think is the fundamental building block of these AI models. I'm gonna go study these things and actually, like, try to create a video where I can help explain it better. So yeah, let me know what you think about the video, and yeah, let me know if you have any questions. I'm super open to answering them all of them. So yeah, life is a gift given by God, so make a proper use of it. I always tell this to myself, before doing anything very important. So yeah, go build, man. Have fun with this shit. This shit is great. Look at this. This shit is so cool, man. Actual robots and actual artificial intelligence is gonna come soon. Take it easy, man. Live. Yeah, I already said this shit. Love you. Take care. Bye.